All right, you made it all the way to module number 3. Let's frame where we are. What we started with in terms of the hacking process is module number 2. In module number 2, we started with footprinting. With footprinting, we find out as much information, both actively and passively, about the target of the attack that we are working on. Once we find that information, then we can take just the useful information and use that information to move forward to the next phase, which is where we are right now in module 3, scanning networks. We can scan the external network. We can scan the internal network. It really depends on the scope of activities that we've been given by the organization. So for instance, if I'm working for the organization on the red team, I may have credentials that I can use on the interior of the network, or maybe even an uncredentialed scan on the interior of the network. Or I may be on a team that's doing a black box pen test of the exterior of the network, at the network edge, the router edge, from the internet. Let's have a look at what we're going to do in this module as we scan. All right, let's have a look. We're going to start off, if you look at the far left side, I almost said right, but it's on the left side over here. We're going to start with just what scanning is. We're going to look at some of the concepts, and then we're going to look at some of the techniques that we need to use for host discovery. Now, I need to contrast because at this point, we're only discovering hosts on the network. Then we're going to move into section 3 here, where we're going to be looking at ports and services. So there's a contrast between the two of these. Next, we're going to look for OS discovery. And then from there, we're going to get a little bit of a preview for a module that we have coming up, which is scanning beyond the firewall and IDS. And then we are going to look at some countermeasures, do an overview of some of the countermeasures. Let's start with explaining scanning concepts here in learning objective number 1. What is scanning? What exactly are we doing when we're scanning a network? Over here we see that we are sending packets into the network. That's what we're doing with scanning. We look at the guy in the hoodie. See that guy right there? You know how you can tell he's a hacker, right? He has a hoodie on, and he has some type of mask on. They're always hackers. No, you actually can't tell who a hacker is. They could have on a tie. You never know. But he's sending packets in to the network, receiving a response back. What's the purpose of this? Find live hosts. Find host names. Find IP addresses that are live on the network. Find ports, protocols, programs that are running on these devices and on the network. We're going to get as much information as we can when we scan. I thought that was a nice poem there. All right, so now what we're going to do is we're going to look at some of the really cool techniques that we can use for scanning. And this is the fact that the TCP header. So one of the areas that's very important to understand when you're dealing with networking is how everything works within each other. We'll talk about this in a little bit more depth a little bit later, but what you have at the very basis, at the OSI model, we look at layer 2. That layer 2 is the frame layer. And so what you have is a frame, and that frame has a source and destination MAC address. When you crack open that frame, what you find next is a packet, and that packet has a source and destination IP address. Then you break open that packet, and what you have inside it is a TCP segment that has a source and destination port. And that's where we are right now, the TCP segment. Each of those areas that I described also has a very complicated header. And that header has all kinds of information that allows for great variances in the way these areas of communication are handled. And so in this case, we're talking about the TCP header. One field in the TCP header is the flags field. Now, if you look here on the slide, you'll see that we have 6 flags. No, I'm not talking about the amusement park. We're talking about 6 of the total of 9 flags that we have. We see urge, fin, rest, push, ack, and sin. So these are the 6 flags that are mainly used for hacking. The others would be ECE, CWR, and NS, although we don't get into those very much in this class. But I'm going to go forward a slide, and then we'll come back. So let's go forward a slide. So if you look at this, what we're looking at is what's called the TCP three-way handshake. When you're on a network that is running the TCP stack, the TCP IP stack, and device A wants to talk with device B, Alice wants to talk to Bob, or in this case, Bill wants to talk to Sheila's computer, what's going to happen is there's going to be a TCP three-way handshake. It starts with a SYN that you see on the far left side on the top, then it moves to the right side, Sheila's computer, and she sends back a SYN ACK. And then when Bill's computer sends back an ACK, we have a open, established, is the actual terminology that we're looking at, TCP session. And another thing you'll notice if you look closely is we have sequence numbers and acknowledgement numbers. These are going to be very important later on as we're able to, in some cases, predict these and then get a hold of that session. If you look to the right side of this slide, you'll see yet another flag. So on the left side, we see SYN, S-Y-N, for synchronization, ACK for acknowledgement. And then on the right side, we have FIN. In fact, we have a couple of FINs that are sent to close the session. All right, let's go back to the previous slide. So what we've done now is we have used 3 of the 6 flags. So SYN, S-Y-N, to initiate, ACK to acknowledge, and FIN to close out a session. Let's look at some of the other flags. We also have urge, which says, hey, this TCP segment is very important. Make sure you pay attention to it. Push, which says, hey, you know what? Dump the buffer now. So now we have all of the flags, and we can use these flags in various ways to cause various reactions to the device on the other end. And the creative use of these flags for hackers like you is called packet crafting. All right, so now let's have a look at this one, and we see, again, we start the session, and when we start the session is said to be established, and then we finish the session, and then the session is closed. And we're going to examine that a little bit more closely as we get into the next section. All right, we're in the next section now. Welcome. And what we're going to do now is focus in on host discovery. Okay, so with host discovery, what are we trying to do? Yeah, you guessed it, discover a host. You just reverse that and there it is. So with host discovery, what we're trying to do is just find live hosts on the network. So is there a computer that's plugged in through its wireless network? Or is there a computer that is plugged in through a wired network? And is it turned on? And maybe I can see it and then hack it later on. We'll get to that soon. But if you look at this slide, what you see is we have a variety of scans. We have ICMP ping, ARP ping, UDP, TCP, and protocol scan. And one of the cool things that you'll see under each, well, not all of them, but most of these, is you'll see the actual command. We're going to get into those commands in just a little while. Now, you also see that it's split up. So the ICMP ping scan also has the echo timestamp and address mask scan. And then the TCP ping scan has the SYN scan and ACK scan. And then lastly, the ICMP echo scan is split out into the ping sweep. And then this is a really great overview because you see a list of the tools that are available. Angry Scanner, Engineers Toolkit, NetScan Tools Pro, Colosoft Packet, Colosoft Ping Tool, Advanced IP Scanner, and OpUtils. And then they show you some of the output of some of the scans here on the far right side for echo and SYN scans. All right, so yeah, we have a whole list of tools that we saw in the previous slide. And just like we've been talking about, we can tell AI to make use of those tools in order to conduct our scan. And I tell you what, this makes it a lot easier. Many times you work on multiple scans and output that scan to a file, and it takes a long time to do the scan and get the results. And with AI, we can make it a little bit easier. Let's go have a look. So what we see here is we're using ChatGPT in the back end, like we've been doing in the other modules. And you'll see that we're using the same old, very nice SGPT command with a chat scan running at in the shell. Scan the target network 10110/24. This /24, of course, for those of you who understand networking, which should be all of you, it means that there are 24 ones in the subnet mask, 255.255.255.0. And then for active hosts, and place only the IP addresses into a file called scanmon.txt. Here's another one. Run a fast but comprehensive Nmap scan. So it's going to choose the Nmap parameters for you. And then this one down here, use Nmap to perform an ICMP echo ping sweep, right? So if we're doing a sweep, it means that we're going to go through a series of hosts or IP addresses. And again, that takes you to the entire subnet, which is /24. And then, fortunately for us, it works really well and outputs it exactly like we asked for. Only IP addresses, and we get the fast scan, and we get the output from the last command, all working perfectly using AI. All right, so now we're going to be looking at various scanning techniques. And we're not just looking for live hosts on the network, but in this case, we're looking for each of those live hosts. Hey, what ports are open? Just as an example, you might have a web server that has port 443 or 80 open. You might find a device that's running Telnet, which is running at port 43. Or you might find an email server that's running with port 25 open, or for SMTP. So we have quite a lot of SNMP, excuse me. You have quite a lot of potential ports, potential services, and that is important. Let's talk about why. First of all, we look at the different scanning techniques. This slide that you see here is your overall slide. And just like the one in the previous section, in the previous learning objective, what I would like you to do, and I didn't mention this earlier, but when you open up your lab, try every one of these commands. It's very important that you learn how they work, how to use them, what types of outputs come out of it. And I want to bring up another point real quick, and that is this. All the tools that we're going to be talking about throughout the entire class, including all these Nmap scans, here's a little secret. Please don't tell anybody. I'll get fired. Most of these things don't work. I know, it's really weird, isn't it? No, actually, it's not weird, because most people defend their networks. And that's why we have hundreds and maybe even thousands of tools and techniques, because that network defender has to defend layers and layers and layers of networking and protocols and application, hardware, firmware, software, everything. You have to defend it all. But for us, usually we only need one entrance point. So that's why we have all these tools. So you're going to be looking at all these Nmap commands. And what if you try Nmap command number 1 and it doesn't work? You try Nmap command number 2, number 7, number 8. Oh, hey, I finally got a result. So that's what we're doing, is rotating through tools and techniques slowly and methodically until we find the one that works. One thing that you find, especially in black box pen testing and hacking, is you have to keep on and not give up until you find that way in. And then if you still can't find your way in, and you've already gone through every technique from module 0 through 20, just ask somebody. We'll get to that in a while. All right, so let's look at some of these methods that we use for these commands. If you look on the far left side of the slide, you see TCP, UDP, SCTP, SSDP, IPv6. Man, those are a lot of TLAs and FLAs. TLA, 3-letter acronym, FLA, 4-letter acronym. Lots of acronyms in this class. So we see that we have various types of scanning, half-open scans, XMIS scans, etc. Let's just go ahead and have a look at how some of these work. Okay, the first thing we want to see is port scanning techniques. And when you see it says TCP Connect full open, that is when we do a TCP three-way handshake all the way. If anybody is watching the network, they'll see that as an established connection. It's very easy to see that you are there trying to hack their network because you're running a full open scan. So another type of scan is to do a half open scan. So with a half open scan, we make use of one of those extra flags that we were talking about before. Half open scan, we send in a TCP SYN. The device sends back a SYN ACK, and then we send in a REST or reset. And we reset the connection so we don't establish the connection, and therefore it doesn't show up as established if somebody's watching the network. It's a little bit more stealthy. Oh, one other thing about this too. If you're scanning thousands of addresses using the Nmap dash lowercase s, uppercase s, which is the SYN scan or the stealth scan as I call it sometimes for the sake of the exam, it is just a couple of milliseconds faster per IP address than the full TCP three-way handshake, which is the parameter dash lowercase s uppercase t in Nmap. And so you can be a little bit faster and a little bit more stealthy using the half open scan. All right, now let's look at port scanning with AI. Absolutely, your AI can do this for you. All you have to do is say, hey, Mr. AI, why don't you, let's have a look and see what we're doing with Mr. AI over here. So the first thing that we're going to be doing is we're going to tell it to use a specific tool. And in that case, the tool is Nmap to find open ports on a specific target. We're going to do a stealth scan. What do you think Nmap is going to do? Well, there are many different ways to make a scan stealthy. And two ways I can think of. Number one is that dash lowercase s, uppercase s. But we also have the aggressiveness of the scan using the timing parameters with a dash uppercase T and then a number after that. T5 is the most aggressive scan. So if you want to sneak around a little bit, you could do a T1 or a T2 or something like that to make the scan more stealthy. And the last one is an XMIS scan. And what you want to do with XMIS scans and several scans like that is have a look at the chart that we've included in this module, because some scans do not work on Windows devices. They only work on Unix devices, and XMIS scan is one of those. And one of the reasons we call it XMIS is because we use multiple TCP flags and kind of do a little bit of crafting, and it lights up the flags like a Christmas tree. That's sort of what it is. So multiple flags. So let's go over here to the other side and have a look at what actually happened with that stealth scan. So what we see here is it said run that stealth scan on 10, 10, 1, 11 and display the results. And so we see here, it sure did that. It gave us the open ports. We see an FTP service that's open. We see that we have NetBIOS and HTTP running on port 80. So it ran that scan. And we got results also for the XMIS scan on this particular section too. So quite a lot of results from our AI. And now let's go to the next one. On this one, let's go to the other side here. You'll see that we are running SGPT again, and it says that we want to use Nmap to scan open ports and services against a list of IP addresses in scan1.txt and copy the only the port and service and version information with respective IP addresses to a new file, scan3.txt. I don't know if I read that 100% correctly, but hey, it's on your slide. You can read it yourself. It's great. And so what we do again is we are actually giving the prompt a fair amount of leeway But in the end, what it does is it takes the scan1.txt, and before we populate scan1.txt, and then we hand scan1.txt over to this process, and then we use it to run the scan. And then from there, we output it, and you see it outputted to a file over here. This is actually very important. Let me talk to you about why it's important. If you're doing pen testing, one of the items that's going to be paramount in the way you do your job is to make sure that you have every one of your results, because you are going to need to put together a comprehensive report that has all your results. So as we go through the class, Module 5, Module 10, Module 15, Module 20, you know what we're going to see emphasized quite a lot when we're running AI is to output the results to a file. And this is extremely helpful. You could theoretically take longitudinal, multidimensional outputs and arrange them in arrays, in spreadsheets, in tables, shove them into databases, all in an automated way to make sure you have the results you need in a format that you want. Okay, so let's talk about services. What is a service? A service is a binary, an application, a program that's running in the background. So for instance, you might have the print service that's running on your Windows system, and that service that's running on your Windows system only kind of fires up and starts running when you turn on a printer. But other than that, it has no interface or anything like that. It just runs in the background. As we get deeper into the course, you'll see that we deal with those on Linux too, and they're called daemons or daemons, D-A-E-M-O-N-S, and they run in the background too. Same thing. All right, so if we look at these services, I want you to focus in on the bottom line on the left side for your exam studies. And I want to emphasize something else too, that a lot of these Nmap parameters, they are pronounced like what they do, right? So SS, SYN-SCAN or stealth scan. SV, service. So lowercase s, uppercase v. If you look at the right, you'll see the command that we're actually using in ZenMap. ZenMap is the application you can run on your Windows PC. And we're just running lowercase s, uppercase v against an IP address. Now let's do it with AI. Everything that we do in this class, we can do with AI. So let's have a look over here. We're going to do chat, SN, shell, use Nmap to scan open ports, MAC details, services running on open ports with their versions on this target. So it'll put together the scan for you and then run it and give you those ports and MAC addresses and versions. Now, in the next module, we're going to see why those versions are so important, because those will help us to get to our hack, which is going to happen in Module 6. Okay, so we can use SGPT and other AI tools, by the way, to do the same thing. In fact, I can go to an LLM like ChatGPT, and I can ask it to write for me an Nmap command that does the following, and then take the output from that Nmap command and then paste it into the interface that I want to use. So there are many, many different ways to use generative AI in order to make things work. All right, so now we're looking at learning objective number 4. And here in learning objective number 4, we're going to focus on scanning, but we're going to find operating systems or OS discovery. All right, so where we're going to start with OS discovery. Well, this is part of an idea that we call banner grabbing. So it's like just snarfing a bunch of information off of the device or the application. It's a collection of data points that we get from that device. So let's have a look at this slide and talk about what some of those data points are. If you look on the left, we have active banner grabbing, get IP addresses, we get information from the TCP/IP stack. If you look on the right, we have passive banner grabbing, which is sniffing. We can get error messages. That's going to be very, very important later on. We get page extensions like from IIS and other services, and it gives us information about that device on the network. So we want to get as much as we can, run a banner grab. All right, so how do we do that? Well, one of the ways to identify the target OS is, instead of using Nmap, we can actually use Wireshark. Wireshark is great. We're going to be using it a lot more as we get deeper into this class. But in this case, what we're looking at is TTL. TTL stands for time to live. And what happens is we have a packet that moves through a network. Let's say that that packet is improperly addressed. And as it moves to the resource, all the routers can't figure out what to do with it, but they all are able to route it. And producing that packet is just moving from router to router. And that packet has been floating around the internet with 16 trillion others since 1993. That would be pretty horrible, right? How many packets would it just be ghost packets on the internet? So what we do is we give them a date, a time where they must self-terminate. Actually, they get dropped by the router interface. But either way, what happens is this packet, if you look in the header for an IP packet, it has a time to live that has a maximum value of 255, and it decrements every time it goes through a router. So what you could do is you could look at the starting TTL, as you see here for Linux 64, BSD 64, because it's Linux, Unix, Windows 128, and you can use that to determine what operating system this might be coming from. All right, so now we also can do the same thing with Nmap. In fact, I would much rather do this with Nmap than Wireshark. It's much more difficult to go through all the records in Wireshark to find that particular one, although you can filter Wireshark to find it. But either way, we just use the -O. Like I was saying about Nmap, for those of you who are new to Nmap, that -O for operating system, SV for version, SS for SYNSCAN. So a lot of these things kind of line up, and it's fairly easy to remember if you spend a little bit of time running Nmap. And like I recommend, try all the commands in the module to make sure you understand every one of them. All right, so if we look over here, the next thing we're going to do is going to do this with AI. So let's have a look at Shell GPT. In this case, I'm telling it to use TTL, hey, time to live, to identify the operating system running on the target IP address. I do that, it checks the time to live, and it gives me a potential IP address. So that's actually pretty cool. All right, so the next thing we look at then with AI is we can use other techniques to find information about the potential device. In this case, if we look at this slide, it says to use Nmap script engine to perform OS discovery on the target IP address in SCAN1. So in other words, we're dumping the information to SCAN1, and now we're using SCAN1 as a source, and it creates a script for us and runs it. And then in this last one in this section, we create and run a custom script. Let me go over to the board. I want to show this to you. This is actually pretty cool. So if I go over to the board, and we see here an attacker can also leverage AI-powered GPT. And what are we doing? Develop, or you could say write, or you could say create. The command has to be something that tells the LLM to create something new. So develop a script which will automate the scanning efforts to find live systems, open ports, running services, service versions. There's an extremely interesting word in this prompt, and that is etc. Unless you're a Linux person, it's etc. But etc. on target. What does that mean? That means that if the command does a lot more than I asked for, that is just fine. In fact, if you want to find more stuff, that's good. So we give the prompt a little bit of leeway on the target IP range, and then we give it a range with that specific subnet mask. So it goes through, runs the command, and one thing we didn't do is, if you look at this, this is just the command running on every one of the IP addresses in this subnet. So we haven't output it. If I'm running that many IP addresses, this is 254 IP addresses on this subnet, you know what I would do? I would output that data to a large file, maybe even HTML, so that I can reference it as a nice little web page and be able to use it from there. All right, so you're running a scan, and like I said, your technique doesn't work. It's not working. You can't get any information back. Why? Because there is a firewall in the way. And this is quite common. Every single network that I've worked with, not only is there a firewall installed on the host, but there are firewalls everywhere. And also at the network edge. And sometimes you have multiple firewalls, like for instance at the network edge, and then sometimes at the VLAN or subnet edge also. And then you have IDSs, intrusion detection systems, IPSs, intrusion prevention systems, and many other things to get around. Now, I'm going to tell you, we have an entire module on this. So this is just an overview. Two items I guess I want to talk about before we get into this. Number one is scanning from the internet into that network, so from the outside. Number two is trying to get out of the interior network. So if you're an attacker, you might want to get out of the interior network because you're trying to exfiltrate data. Or you might be an employee who just wants to get to some resources outside of the network. So we have a couple of different standpoints from which to view this. Let's jump into it. All right, so the first one that we see here is some of the techniques overall. This is the overview of the module. Let's have a look at these, and then we'll get into each one of them. Number one is packet fragmentation. Number two is source routing. Number three is source port manipulation. Then we have from there IP address decoy and spoofing, MAC address spoofing. And then we go to creating custom packets, that's packet crafting, and then randomizing the host order, scanning with bad checksums, and then proxy servers and anonymizers. Oh, that's quite a lot. And it's pretty fun. So let's have a look at the first one. The first one is going to be packet fragmentation. So fragmentation is something that naturally, it's all artificial, right? We're using computers, but that naturally occurs. So if I have a frame, embedded in that frame is a packet, and for some reason, I can't get all the information through a resource, it might fragment, take that packet, put it in chunks, and then wrap a new frame around it. And then as those packets make it through networks, various routers, etc., and they arrive at their destination, with TCP, you have sequencing and acknowledgement. So what will happen is I'll take all the fragments that are in sequence, I will acknowledge each of those fragments until I fill my TCP window. I will sequence all those fragments until I fill my TCP window, and then acknowledge that I've received everything, and then the sending device will send more. So that's what's happening with TCP. So fragmenting is already available, but what we can do is we can create a novel, they're not super novel, but use packet fragmentation in creative ways. I guess that's the best way to put it. Use it in creative ways to fool the network edge by various means. So let's have a look at this. So what we're doing here is you have the TCP header. We're modifying it. We're modifying the packet itself. We're using packet crafting techniques. They're showing you an example on the right using SYNFIN scanning with fragments. We haven't talked about all of these yet, so let's go ahead and talk about all of these. So right over here, we have SS. SS is a SYN scan. What a SYN scan does is it creates part of that TCP three-way connection, then it resets it. Over here, we have a T4. What is T4? T4 is the fourth generation model of the Terminator robot. No, it isn't really. What it is a highly aggressive scan. The most aggressive scan you can get with this timing characteristic is a T5. And this is very nice when you are on a network that is a virtual network or a test network. All right, the next thing we have is a -A, right? So A, alpha A. What that is it's kind of like a little banner grab. I always call it dash all, A-L-L, like it does everything. Even though if you were to look for the designation, that's not what it really means, but it helps me remember it. The next thing we have here is, and I'm going to go to the top over here, you have a dash lowercase f, and that is the code for fragment. And I don't want you to get it confused because there's another dash f that if you do it wrong, you'll get the wrong thing. And that is dash uppercase f. So what is dash uppercase f versus dash lowercase f? Let me ask you a question. If you were to run an nmap command, like nmap space, let's do dash ss like we see here, and then give it a target. Let me ask you a question. How many ports will nmap scan? The answer is the top 1,000 most useful ports for scanning and hacking, right? That's what it'll give you. And so if you don't specify a port, and by the way to specify a port is with a dash P, right? If you don't specify a port, then it'll do the top 1,000 most useful ports. What if you want your nmap command to go faster? That's what this is, fast. So now this is going to go faster. How does it go faster? Instead of doing the top 1,000 most interesting / useful ports, it does the top 100. So that is almost an order of magnitude faster than the scan without port designation. So don't get those confused. This dash lowercase f is fragment. And then lastly, I'm going to move over to the left a little bit here. We have dash v, lowercase v. Do you know what that means? Yes, I know you do, right? It means verbose. That's what that means. All right, so that's what we have. Zooming in on each one of these things. Remember, the uppercase f is different than the lowercase f. It's for fast. And the lowercase f is for fragment. And so with fragment, it's a really cool thing because we have the ability to send all these little teeny packets across the device. Let me close that out. Across the device, across the firewall. And there are so many of them that they don't get put back together, reassembled, and we might just make it past the firewall. But if that doesn't work, don't worry, there's more. The next thing we can do is source routing. So let's say that I'm trying to scan behind a firewall. But you know what the problem is? There's a firewall, and I really want to get behind that firewall. But in doing a little bit of work, I find that there is an IP address on the same subnet that doesn't get used very often. Why not? Well, because when you are on the internet or in routed networks, the faster the connection, that route is preferred, orders of magnitude above other routes. So let's say there's a 10 gigabit per second connection. And then there's another path. And that path is a 3 megabit per second connection. What is it? What do you think goes 3 megabits per second? Old DSL. Or even worse, 40 kilobits per second. Many times this has happened to me. I go on a customer site and we're talking about the network. I'm walking around with the network team. I'm walking around with one of the managers, and I have told them that, hey, it's time for us to have a look at all the resources that are in the data center. So we put the code in the card, open the door to the data center. We all go in, and I say, hey, do we have any pullers? Let's get these tiles pulled. And we start, they're like little suction cups, and we pull all the tiles and we stack them up. And then it's really weird because now you have to walk in between the open spots where the tiles were for the raised floor. Data centers have a very loud sound because of all the fans that are going in there. It's really cool being in a data center. Some of you know about that. You work in or have worked in data centers. But either way, what we're doing now is we're looking what was under the floor, and we're tracing out all the cables and what they connect to. Most of those bundles go to server racks, and they plug into, and sometimes they're overhead and they go all the way to under and so on. But every once in a while, somebody in the team at that company says, wait a minute, what is that? And there are these little blinky lights, and we get closer, and sure enough, it's a modem, a dial-up modem, and it is on. oh my, where does this connect? And we find out that it's part of the network and nobody even knew about it. So yes, another slow speed path that you might find your way into a network is through a dial-up modem. But like I said, on the router advertisement, that'll be something that is never, literally never used. In some cases, it has never been used. So what we do is we do source routing. So if you look at this slide, you'll see that we're going around that firewall. How do you do that? You just write your own router rules and you make the path through that modem or DSL or whatever the preferred path, and then your packets now go the other route. Interesting, huh? All right, so now let's have a look at source port manipulation. So if we look at source port manipulation, there's a problem. I'm hacking. I'm working on hacking. But the problem is with my hacking that when I send in my packets into the network, they're coming from my machine, and my machine is randomizing the ports that are being sent to that target network. And the edge network device says, excuse me, I don't do random ports, bro. It doesn't do random ports. I'm in big trouble. No, I'm not. You know why? Because I can do a -G and then give it a port that that firewall likes. Hey, port 80, port 443, we're all buddies here. Surely you'll let port 53 through. And now that I'm port 53 or port 80, I can get through. So that's called source port manipulation. That's one you should know also. -G works great for that. All right, so the next area that we want to explore is taking some of these commands, some of this information that we've discovered, and use it in different ways. One of the ways we can use it is to create a decoy. And a decoy makes it so that that edge device has trouble discerning where the actual communication is coming from. So with a decoy, we can use a $D and give it either random or make up IP addresses. And so we have all these multiple IP addresses from which the attack is coming. But wait, there's more that we can do to get around that firewall. And this is spoofing the IP address. Wait a minute, why would that work? Why, if I have IP address 7.7.7.7, would that be any different than using IP address 10.10.0.7? Why would that be any different? And this is something else I've seen at customer sites. I go to the customer site and I'm going to their firewall and I'm reviewing all their firewall rules. And I'll say, wait a minute, why is 10.11, I'm going to use an internal address, even though I'm talking about an external address, 10.11.11.11, why is that IP address allowed through the firewall? And they'll say, I don't know. And so what I'll do is I'll comment out that one. So we'll find anything we don't know what it is on the firewalls and comment them out. Then we wait. So I'll work on other things in the project, and eventually there'll be an angry manager calling back and saying, why can't I initiate my application, meeting, whatever it is, from his home computer? And that's what that IP address was. So if in the firewall, there is a firewall rule that will allow a specific IP address to get through, then I just use that IP address and bada boom, I'm through the firewall. And another thing that we could do is spoof MAC addresses. And this has a lot of utility also. And I spoof MAC addresses for various purposes, but sometimes it's so that that device on the other end will allow the type of MAC address I'm using through. So if you look at here, we see we're doing a spoof MAC, but over here, this is even better because I'm telling it I'm a Dell computer. So I can tell it I'm a different type of computer and maybe allow it to, or coax it to let me get into that system. All right, I was talking about packet crafting before. So packet crafting is when we take that packet, we manipulate the flags, we fragment it, we try many different ways to make that packet able to get across that firewall or IDS or IPS. And one of the best tools, and this is another tool, the next tool is Colosoft Packet Crafter. Now, I will say this, that there are other tools that you can use to create custom packets. Nmap actually has an ability to do some packet crafting, and so does HPing allow you to do some packet crafting. So it's actually an array of tools that you can use for this. But Colosoft is the preeminent tool that helps you craft packets. Okay, so what's one of the things that you can do? In this case, we're going to move from Colosoft and go into Nmap, as you see here. Let's have a look at what we're doing here. On the first illustration here, which is on the left-hand side of your screen, what we see here is we're randomizing the hosts. So let me show you what the command that we're using in order to do that. It's -- randomize - hosts. What are we doing? Why would I do that? Imagine that you are a firewall and you see that there is an outside IP address that's tickling IP address 10.10.10.1, 10.10.2, 3, 4, 5, 6 sequentially, right? Every few dozens of milliseconds. You're like, you know what? That's an attack. Let's block that. So instead, you do randomize hosts. Now, that will scan all the hosts in the target network, but in a random order. So if you look at this command down here, really, this would probably be a subnet command, not a single host. So you do 10.10.1.0/24. All right, let's move over and have a look at bad checksums. In the TCP header, there is a nice little area called checksum. What is checksum all about? Well, what it does is down to the bit level, it makes sure that not 1, 1, or 0 has changed in the transmission of this TCP segment. If there's a bad checksum, and we're going to see this come up over and over again, by the way, if there is a bad checksum, then it will stop examining that communication because it assumes that it's going to be dropped and it's a bad communication. But it's a fake bad checksum. It makes it all the way through and we can scan the host. So in this case, we use -- sum to make that work. All right, so we have bad checksums, we have random order. Now let's talk about something that works really well, both coming from the outside, scanning to the inside of the network, and something that works very well from the inside of the network going out. And that is proxy servers. So if I'm on the outside of the network, scanning towards the inside of the network, and I use proxy servers, especially proxy chains, it's very difficult for the target to know where I came from, hiding my identity. But if I'm on the inside of the network, and let's say I'm on the inside of the network, and oh no, I have this new job and I'm getting the shakes. It's my addiction. I must have Facebook. I just have to have a hit of Facebook. What do I do about that? Well, they won't let me go to Facebook because when I type in www.facebook.com on my keyboard, it gets blocked. So what I'm going to do is I'm going to open up my browser, go to the LAN settings, and set up a proxy server. And then I'm going to go through that proxy and get to Facebook. Woohoo! All right, that doesn't work all the time because any organization that's blocking you in any way will likely block proxy servers too. So that is one way that you might be able to make it out of the network. All right, so let's have a look at the next learning objective, and that's number 6. And number 6, we're going to look at countermeasures. So like I said, at the end of every module, we'll hit some countermeasures. Most of this will be an overview. Let's roll. All right, so when we look at countermeasures, we want to stop ping sweeps. People like me, we're going to try to grab as many IP addresses as possible. And one of the areas that we want to do is make sure we lock down our firewall, use IDS, use IPS to make sure that we avoid ping sweeps. Also, if you look at that top one, a lot of pings come out, well, it's a ping. It's going to come out of ICMP. I can also control the use of ICMP from that network edge. And in controlling it, I can use like the number 4, terminating the connection, with more than 10 requests. Why? Because they're probably running a scan. And we can use a DMZ. We can change ICMP headings like for echo reply and host unreachable, et cetera, in that DMZ. We can set up ACLs. Again, that's using ubiquitous IAM or ubiquitous identity to secure it. Also, I mentioned an IDS, that's number one over here. We can also run tools that look at the network and can tell that a port scan is happening. We can run tools that look at the network and find that a ping sweep is happening. We can use tools that actually look for the use of tools like Nmap and other tools on the network and then stop them from scanning. We can also use anti-spoofing tools on the network and do our own pen test, TCP and UDP, to find out what's going on with the network. And we can also disable or change banners. So for instance, let's say that I have a Cisco 2800 series router, and if I scan it, look at the banner, guess what the banner is going to say? Cisco 2800 series. So I might want to make that a different banner, like I can make it an HP printer banner. Maybe somebody might want to hack a router, but not a printer. Or I could just disable banners. And then here on the right side, we can hide file extensions from web pages, and that will help that web server not advertise the fact that it's a web server to the internet. Moreover, we can disable or detect, in this case, IP spoofing. Let's talk about how IP spoofing works. Okay, so when I'm spoofing an IP address, let me move over here and talk a little bit about this. I'm coming in, that's me right there. That's my hoodie and my little laptop with, yeah, that's me. And so I'm sending in a spoofed IP address of 10.0.0.5 with an IP TTL of 13. All right, I get through the cloud, I come onto the local network, and in communication, I want you to notice something. My TTL is 13, but the TTL inside is radically different. Why? Because on the outside, I cannot respond to changing TTLs, so there's going to be a massive differential. In fact, very similar to that is the IP ID. This is the IP identification number. And again, on the outside of the network, that IP number, the IP ID is going to be massively different on the outside of the network to what it is for the same IP address on the inside of the network. So if I can determine that differential, then I know that somebody is spoofing an IP ID. On top of that, we have flow control. Let me talk to you a little bit about flow control. So with flow control, that is a TCP capability. It's actually really cool. So let's say I have computer A over here and computer B over there. Well, I should probably draw it on the board, but I'll do that later. We have computer A over here and computer B over here. Computer A sends, let's say, 1,000 TCP segments to computer B. Computer B takes those segments, sequences them all together, and then acknowledges, says, hey, send 1,000 more. Computer A puts together 1,000 more segments, sends it to computer B. Computer B says, thank you, I got those all put together. ACK, send more. All right, so this happens one more time, but on computer B, somebody has started a very taxing set of processes on computer B. It's too busy to take 1,000 segments. So in the next communication, it takes that window of 1,000 segments and it shrinks it. And it says, send 10. So we now go from 1,000 segments to 10 segments. And so computer A will send 10 segments over. That is the TCP sliding window in a nutshell. It's a lot more complicated than that. On the outside, I may communicate with a specific window, but on the inside, it does not match. And so we're like, yeah, that is a spoofed IP address. So that's another way for spoofing an IP address and how you can tell that that IP address has been spoofed. All right, so what about countermeasures for IP spoofing? There are many things that we can do for that. If you look at this slide here, look at number one. What was I saying about countermeasures? And the most important countermeasure at all? Ubiquitous encryption, right? So multiple firewalls, IP detection, authenticate. Hey, look at that. Number three, we're talking about authentication. But remember when I said that sometimes there's a hole in the firewall to allow a specific IP address? Do you know that you can set up a firewall just to let a specific IP address through without any ACL? That's called IP authentication. You don't want that. Ingress and ingress filtering, anything that goes in and out of the network, random ISNs, those are very good. All right, so in this module, we have been talking about scanning. And what I would like you to do is when you get to your lab computer, in fact, if you haven't been following the labs, why don't you go ahead and look at your instructions and open it up right now and look at the IP addresses that are in the lab. And I'd like you to take all the Nmap commands that you see in your courseware and in the slides that I've been going over and try all of them. Make sure you understand what they do, and then get some that seem to work for you and practice them. All right, so the next thing we're going to do after going through labs is we are going to get into the last section before we crack into that computer system, and that is looking at vulnerability. And that brings us to the end of this module.